Okay, 9 hours. Okay, the question is asking, is stating that the information that the question is given is that vehicle 1 leaves the station at 25 miles per hour. Vehicle 2 leaves at 30 miles per hour. Vehicle 1 leaves at 3 o'clock. Vehicle 2 leaves at 4:30. How much of a time delay is that?
1 hour and 30 minutes.
1 hour and 30 minutes. Very good. But we can't put 1 hour and 30 minutes, can we?
No, sir. 1.5 hours.
125. 1 point who?
1.5 hours.
Very good. 1.5 hours. So the table that we're going to set up will look like this. Vehicle 1 is going to leave at, and we'll just put rate above here and time above here, at 25 miles an hour. The unknown is going to be t, but the difference is we have a 1.5 hour head start, so we have to add plus 1.5. This represents 1 hour and 30 minutes. As far as our vehicle 2, I'm going to just put the 30 here, and then I'm just going to, all right, so we have 30 times t. So the combination of these two are going to equate to the same amount of distance. All right, so in order, we're going to make ourselves a little bit, we're going to take the combination of those two equations, and it's going to look like 30t times the unknown, the rate times time, is going to be equal to 25 times the sum of our unknown time plus 1.5. This is the slower vehicle with the head start, so we'll do that. We'll put that there. So what's going to have to happen here?
You have to multiply 25 through, and
25 is distributed.
37.5.
Okay, so we have 25t, and then 25 times 1.5 is what?
37.5.
All right, plus 37.5. So what happens at this point is $25t is subtracted from both sides, and what do we get?
5t equals 37.5.
And what is our time?
The time is 7.5 hours.
Okay. 7.5 hours. So it will take vehicle 2 7.5 hours to catch vehicle 1, correct?
Not including the delay.
Not including the delay.
Or is that including the delay?
Yes, it is including the delay.
Okay.
Has to be, because you made the adjustment for it here.
Yes, sir.
When we put in the t plus 1.5, that accounted for the delay. And this is why we make them, because this is a function of vehicle 2, and this is a function of vehicle 1. And we make it equal because rate times time and rate times time, they're going to have the same distance once the whole time is transpired. So that's why that's what we're solving for.
Okay.
All right. We're going to try another one. Not so bad, because I just want you to be a little bit more razor sharp when it comes to these. All right. So here we go. Vehicle 1, train 1 is going to leave the station at 30 miles an hour. Train 2 is going to leave the station at 50 miles an hour. And I've assigned V1 and V2 for the particular items. All right. Now, so these are the rates. Time is going to be unknown automatically. All right. But with a delayed departure, what I call a delayed departure question, what's going to happen is we're going to have to assign time because it gets a head start. So vehicle 1 gets an hour head start. So what do I need to put here? I'm going to add something. What I'm going to add there if it gets an hour head start?
You're gonna add that hour.
Okay, I can add 1 there. So now, what is our equation going to look like when we set this up?
50t equals 30t plus 1, or like 30 with the parentheses and t plus 1 inside.
Very good. So 50t equals 30 times the sum of t plus 1. 30 gets distributed into there, right?
Yes, sir.
And what do we get?
30t plus 30.
Very good. 30t is 30 times t plus 30 times 1, which is 30. And so this comes down, all right? And then 30 is subtracted from both sides, all right? And what do we get here now? Because 30 is subtracted from both sides.
20t equals 30.
Okay, so if 20t equals 30, what is the definition of t? Now, I have a rapid math point here. When I look at this, do I need to deal with those zeros?
No.
Okay, so I can't talk this morning. I already see 1.5 hours. I already see it, because 3 divided by 2 is 1.5. All right, so it's going to take vehicle 2 an hour and a half to catch up with vehicle 1. And just for, like, you could go through the motions of doing this, 20 divided by 30, you're still going to get 1.5. So what I suggest is you cut off the zeros and just 3 divided by 2, 1.5 is going to be your answer. And we still get the same answer. So the only thing that we need to remember is that we need to chop off the correct amount of zeros in that case. Okay. Composition of the atmosphere. How much oxygen, or no, how much, what is the, we have a 78% item, we have a 21% item, and then we have a 1% item, which are trace gases. And I'd like you to define the trace gases.
78% nitrogen, 21% oxygen, and the 1% is...
What was my memory aid for that?
Where'd it go? Oh, see if I can find it in my...
I'll just give it to you for our purposes. There's a C, there's an A, there's an H, and there's an N.
Is it C carbon?
Carbon dioxide.
Carbon dioxide.
A-R-H-E-N-E. I'm just giving you the first 2 letters of each one just to jog your memory. I know it's early.
Is A argon?
Yes, it is. Argon.
He is helium.
Helium.
Does that say Ne?
Yes, it does, sir.
Yeah, I'm drawing a blank on that one.
You go into your favorite bar, and it says Budweiser here, or Michelob Light here. What kind of sign is that going to be?
Neon.
Very good. You're going to remember that, watch. You're going to be like, the composition, yeah, Kieno was talking about the bar. Yeah. So that is the 1% combination of trace gases. Okay, good job. All right, if I told you that we have a right triangle and one side is 3 and one side is 4, what would be the length of the hypotenuse?
5.
Very good. If I told you that we had another right triangle and the one side was 30, not talking about the hypotenuse, and the second side was 40, what would be the length of the hypotenuse?
50.
50, because we know something about 3, 4, 5 triangles, right?
Yes, sir.
Okay. Now, if you did not have that scenario, if I told you we have a right triangle and we're talking about the two sides, not the hypotenuse. Side one was 5. Side 2 was 9. What could we use to define the side C or the hypotenuse? I'll just put HYP for
The Pythagorean theorem.
the Pythagorean theorem. And what does the Pythagorean theorem state? Or how's it written out?
A squared plus B squared equals C squared.
Very good. A squared plus B squared equals C squared. So let's, for our purposes, A will be 5, B will be 9. All right. How do we find side C? I want you to talk me through it. You're the teacher.
You want to square both 5 and 9 and then add those together.
Okay, so 5 squared plus 9
25.
squared. Looks like, does that look like I'm going in the right direction?
Yes, sir.
Okay, and so then the 5 squared is going to be 25. The 9 squared is going to be 81, and that is going to be equal to C squared. All right. So then we'll go over here to the side. We'll add 81 and 25. We will come up with a number of 106. Is that correct?
Yes, sir.
Okay, that is a very nasty number because it's going up against C. It's going against C squared. So in order to, and we won't go because we're going to do other questions relating to radicals in a moment here. What would the distance, what would C be equal to given this information?
Well, I got square root 106 real quick.
Okay. If you can, because it may not even be doable. Could be. Actually, it is. I see it now. Nah, maybe not. Here, I'll just do my little thing on the side. We have the number 106 and factors 1 and 106 are factors. 2 and 53 are factors. 3, 4, 1, 66. That is a weird number. But like I said, we are going to wind up doing a little so, but I don't believe that this breaks down into anything neat. And I see that, yeah, it really doesn't. Because if I do it by calculator, it is 10.29.
Gotcha.
Alright, and that would be like virtually impossible to do by hand without a calculator like you would on an AFOQT. And these sides were just basically kind of just thrown out. So since and I'm sorry, just let me get myself adjusted over here, if you don't mind, sir. Okay, so if I gave you, because we're going to get into the square root workout in a second here. If I gave you, I'm just trying to look up some exercises here, and I found them. All right, so if I gave you the square root of 18, how would I solve that? What would be my answer?
You could break it down into square root of 9 and square root of 2, so you would get 3 root 2.
Okay. And what is my memory aid for working with square roots? Do you remember?
Yep, I got it written down. It's got a pattern to it. Where's that pattern?
Or I'll just start writing it down on the side just for time purposes. 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81. So basically what I'm doing is I'm looking for factors of 18. And what I mean by factors are two numbers that can be multiplied to get the number 18. But the thing is that I'm looking for one of these hot numbers. We'll call these hot numbers when we are looking to solve. And you pulled a hot number, because if I was sitting here and me, I'd say, what are factors of 18? I'd say 1 is a factor in 18 because 1 times 18 can equal 18. And then I'd say, okay, 2 times 9 are factors of 18 because 2 times 9 can equate to, 18. It's a little early for me. But we got a hot number here. Ding, 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 ding. Boom. In our list, we have a hot number. When we have a hot number, and that's just the term that I give it, it's a hot number because now we have something to help us find the answer, okay? 1 does not, we can't call this a hot number because anything, 1 is a factor of like every number, even itself, so that doesn't count. So above 1 is a number, so we have 9. So 9 and 2, because 18 is equal to the square root of 9 times the square root of 2, all right? And when we take that into consideration, we keep the number that's going to break down on the left because our answer is 3 root 2. That is our final answer. Okay. So, boom. I'm gonna give you another one. I want you to tell me if you see a hot number. Square root of 32. What are the factors of 32, first of all?
1 and 32.
Mm-hmm.
2 and 16, which is a hot number.
16 is a hot number. Ding, 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 ding. We got a hot number. All right, so 16 is our hot number. Now, how do we set this up? We are going to have 2 square roots.
You want to put the bigger number in the front because it's going to...
Or the hot number.
Or the hot number in the front because it's going to evenly square root.
So 2 times 6. 2 goes under a radical sign, 16 goes over the radical sign. What's our final answer?
4 root 2.
4 root 2 is our answer. Good job. Okay. Let's look for another one. I got tons and tons and tons. Okay. Yeah. What is the square root of 75?
I'm thinking 25 will be a part of it.
Okay, very good. That is a hot number.
25 times 3.
Square root of 25 times the square root of 3 because these are both factors of 75. A final answer, sir.
5 root 3.
5 root 3. Good job. Okay. I don't really waste my time with what's the square root of 100? What's the square root of 49? What's the square root of 64? Because these are included in our hot numbers. Okay.
Yep.
So these are like easy. These are easy to solve. These are easy. Because this is 10, this is 7, and this is 8. All you have to do is just write on a piece of scrap paper, what's 1 squared? What's 2 squared? What's 3 squared? What's 4 squared? Alright. Alright. So what is the square root of 1,000? Let's get really dirty.
Ten root 10.
10 root 10. And what factors did you use, sir?
110.
110. because 100 times 10 is 1,000. Put square roots over them. The 100 breaks down into 10 and root 10. So ultimately it is the same thing because the square root of 100 is 10 times square root of 10. So that's why our answer comes out like that. Okay, very good. Now, if I gave you, let's say I said, what is 5 raised to the 0 power? What would you tell me?